done. I just need to make sure that we have a recording going.
Yeah, yeah.
Got it. And then work. Okay, we're done. Okay, so we have Linda, we have Gabriela. Okay, so everyone's joining. Perfect. Hello, everybody.
Hello, Chris. Hello, everybody.
Hey, Gabriela.
How's everybody? Do you
Hello,
want me
Linda.
to use a background, Chris? If you want, you can send it to via WhatsApp.
Yeah, let me see if I can find the background really quickly to you. We're waiting for one person, for Katrin Maronek to join, and once we join, I'll just walk you through the
Yeah, but
stuff
if you want to send the background, I'll just put it
I'm
in
working
because
on that. I'm working on that right now.
Leo, nice to meet you. You're muted.
Yeah, I will unmute myself. Nice to meet you, Linda. Thank you very much for the invitation. It's very interesting.
Can you make me a co-host, Chris?
I'm working on that.
Okay. All right.
Give me a second. Just need to extract this data chapters. Media. Okay. Perfect. Okay, and Gabriela, let's see. Okay, just send it over. Okay, and then let me make you a co-host. So,
Hi, everyone.
Hi, Gabriela. Nice to meet you.
Hello,
Nice to meet you too.
Yeah.
I need that background because, yeah, let me just get the, because I just arrived in Philadelphia, so I'm like using the hotel office.
So you made Matt a co-host,
and
not
I made you
me.
No,
you did?
Yeah,
got it. Great. Yes. No, I got it. You're right. You're right.
All right. Let's start nudging Katrin in 3 minutes if she doesn't show up.
Okay. I have her email here. Let me see if I oh, I'm not sure your version of Zoom allows for the closed captioning.
So I looked into that, and what they told me is that you can buy like an app on top of it, but
yeah, that's what I was afraid of, that this version didn't have it.
It's like an extension, the same way, because we have a little bit problem with timing of some of the speakers. I wanted to put a timer in the back, but yeah, that didn't work very well. Matt, do me a favor. Can you prepare the same short bios for the speakers tomorrow, so I can send everything today to the other people?
I think Tyler already had all that done. The bios. I think he sent it already too, actually. Okay.
For tomorrow?
Yeah, I could double check, but I'm pretty sure Tyler already sent that yesterday.
Okay, yeah. I will have to look for that. Okay, so that's not the thing. And
there. Or do I appear like? Do I have to mirror this, Chris?
Good. I can read.
You see it correctly? You see SHCI, or you see it like a mirror?
No, I see you correctly.
Yeah, that's strange. Okay.
So I can read it without much of the.
No, that's fine. That's fine.
I would say so.
Okay. we're all set. You know, we need the looks
Need
first.
the last, we start.
Okay, perfect. So great to meet you, everyone. Now I feel like I'm done. I'm all set up here. Thanks, Chris. Is it too dark? I have a window here and nothing here.
We cannot see you, we just see your banner.
Okay, so Leo, nice to meet you. And
Nice meeting you, Gabriela.
are you ready? Leo, you are looking a little bit like dark. There is a setting in Zoom.
I probably just should switch
No,
the light.
that's fine. That's fine. The light is fine. But you can adjust it in the computer. So if you go to where you have the little camera down there in Zoom,
Yeah.
there is a little the arrow up facing arrow.
Yes.
So if you click on that, you go to video settings.
Yes.
And there in video settings, you can either, if you want, you can touch your appearance if you want to. If you don't, you just can allow manually adjust for low light.
Yeah.
So you put manual and then light it up. So then all of your space gets lit up.
Something like that?
This. Much better.
Oh, wait a second. Is it better? Okay, very good.
Yeah,
I
much
guess
better.
Who spends all the life in the Zoom.
Right, like this.
Then I think the touching your appearance, I've been playing with that, but it doesn't do much. I think there's nothing you can do with your appearance. I thought it would, beautify you, but it's not we're not in the air, right?
Nothing can beautify me. So.
We cannot be improved in that way, right? Yet.
Sure.
But there are some things that I haven't tried, and there are you can have more eyebrows, more lips and things like
that. Chris, I can add, what is it? I can, if I have the videos, I can add the captions by replaying them through Zoom, because we have that capability. It's the
what do you mean by replaying them through the Zoom?
Okay, so we're recording all of this, right? And what happens if I play it, if I watch the recording on Zoom, we have the closed captioning capability, I think because we're an educational institution and we have to, so, but if
I just download all the videos, so I can give you access, and then you can just send them through.
You do have, I'm sorry, you do have the videos, right?
I hope so.
Okay, no, I'm sorry. I just didn't hear the word. It cut out a little bit. You said okay. All right, cool. All right.
Let's see.
Thank
do we
you.
have a Katrine, or we don't have a Katrine?
Oh, that's right. Oh, I'm sorry. Focused on so much. Hold on.
Catherine sent an email a little bit ago saying she would be logging in soon. I'm not sure when soon is, but at least you acknowledge that she's going to go.
So, Chris, do you want to walk us through, the whole process?
Yep. So let me share my screen very, very quickly. So this is okay. So this is a slide deck that I'm using just for start. Okay. So now about the role, Matt is our tech guy. Tyler is one of our supporters, but he's going to listen to the back end. Gabriela and Linda, you the moderator. Leo and Katrine are the presenters, and I'm just doing the tech. So for this session, so pretty much I will welcome everybody. We will talk very briefly on the second slide. What are the Santa Cruz and SHCI are about? Then I'm going to hand this over to Linda, and I will be very, very, I will say, Linda, over to you. And she will introduce our speakers at this stage. Okay. Then we will talk. Then Linda will continue and introduce our moderators. Unless Linda, you want me to do it?
I would prefer you to do it if you don't mind.
Okay, so just Chris, over to you, and I will introduce Gabriela and you, Linda.
Okay, it's
then-
MAC.
Do you want me to introduce the speakers, Chris? If you give me the
Yeah.
bios to read.
Yeah.
Then we talk, this is our format. So introduction is the beginning. Then we have a presentations. Then moderator Q&A, that means you, Gabriela, and you, Linda, will pretty much ask the question pertinent to the presentation. Because Katrin is not there, by the way. Leo, you will go first to present. Okay, if Katrin has a strong feeling, we can address this then. And then what happened is we break the people. If we have yesterday we have a 40 people plus, so it was easy to break. People will go to the room for around 10 minutes. We should make it shorter, and then they will come back and we will try to pull the questions out of them. If there's no questions, it's a moderator role to sort of make sure that discussion is flowing. The question will be posted in the chat. We will monitor the chat. And then around 3:30, we sort of close everything. Okay. Every time I will use the name of the person who I want to take over from me. And I think every time you guys want to take over from, you want me or Linda, or whoever takes over, just use the name at the end. And that should kind of work best. All right, so that is the layout. This is a format. This is netiquette. I'm just going to, pretty much talk very, very briefly about it. And then after the netiquette, I will say, Leo, please start your presentation, and we'll let you go ahead with that. And then presentation number 1, no break. Presentation number 2, and then you moderators take over. Okay, so that's pretty much how this will go. Any questions?
Yes. Chris, do you want me to present the speakers to change a bit? Can you present the moderators?
What do you prefer?
That would be great. I would, if Chris, if you don't mind, that would be great.
So I would say, Gabriela, over to you for the speaker presentation, and boom, done deal.
No, you put up the presentation, but no. What I mean is, like, you have a short bio of each speaker, correct?
Yeah. So
we do.
You will talk the bio. Okay, correct?
Yeah, it's in the presentation. You're meaning?
The bio is in the flyer, but it's not in the presentation. Okay, let me send that to you right now. Let me send that to you if that's okay. Thanks.
So I'm going to ask you, Gabriel, to present our speaker based on those bios that Linda is sending right now.
Okay. Are you sending them via email?
Well, I was going to send them right through the chat if that's
chat.
Okay.
Perfect. Yeah. That's
okay. Oh God, no. This okay. You know what? I can hold on. Maybe I can.
What are you doing? What are you going to do?
I got it. I know. I'm sending it via the chat.
Or you can send it via WhatsApp, Chris, to me.
Yeah, that's actually what I'm working with. Have both ways.
Catherine's in the way, so I'm going to admit her.
Yeah, I mean the Catherine. Okay, perfect. So Gabriela, stand by.
Yeah.
For the email. And okay, perfect. We have everybody. All right. So let me see. Okay.
So do I look for the bios where, Chris, and
WhatsApp? Stuff is coming on WhatsApp right now.
Perfect.
Okay,
thanks.
And then go for this.
And you do, Chris, you do all the cutting and pasting of switching the screens and the groups.
Yes,
you do all that.
I'll do the switching. Okay. So Katrin is here, correct?
There she is. Yeah.
Catherine,
okay.
and I want to make sure how to pronounce. Is it Leo Peterson? How do I pronounce it? Leo Peterson.
Yes, it's Peterson. You can just drop Khmelnytsky. I'm going to drop it soon anyway.
Okay, Leo
Nobody
Peterson.
can pronounce it. Yeah.
No, we can learn. So it's Leo, but Leo or Leo.
Yeah.
Leo.
It's Leo.
Leo Peterson.
Yes.
And Catherine Myronik.
Myronic. So it's like the word ironic, but with an N.
Oh, Myronic. Okay, Catherine,
yeah.
But Catherine, right? Catherine Myronic. Nice to meet you, Catherine.
Okay.
By the way, nice meeting you, Catherine.
we have everybody, so let's just go through the lineup again. So I will present the conference. Then I will talk who are the organizers. Then I'm going to ask you, Gabriela, to present our speakers. Then you will hand this over to me for the presentation of the moderators, which I will do. Then I will very briefly describe how this is the format. So 10 minutes introduction, presentation. We decided that Leo go first and the Katrin goes second. So no breaks between the presentation. Then the moderators, which is Linda and Gabriel, you take over from them and ask questions based on the presentation. We most likely will do the break rooms, for 10 minutes. After that, again, back to you, Linda and Gabriela, to ask the question either from the break room or ask the question based on your desire. At 3:30, we closing, and that's pretty much it. Any questions? Okay. Every time I want somebody to talk, I will use their name. So I will say, Leo, up to you, or Gabriela, is take over. So there is sort of clarity how it goes. If something got suspended, on my end, we both Linda and Matt are the host. So, we can always go back. All right, any questions?
Perfect.
All right, so I'm going to run the recording. Okay, there's a link on YouTube. Let's start the meeting call. And Matt, if you can keep admitting the people, that would be great.
Yep.
Okay, perfect. We're going to give people a little bit wait, but you can always do the poll. So this is just kind of warm up. So when do we think there will be a new pandemic?
A pandemic?
Yeah, it's a hard subject. So let's see, the doomsday is going to be, by the common knowledge, in 2 years. Damn it, I have to buy the more Pfizer stock, obviously. Okay, so let's see. So this is the results. Definitely 2024, and a lot of lack of knowledge. So that's one thing. Okay, just for fun, we can do another poll and then we start. So what do we think about the state of innovation, and what do you think is the hottest innovation, and what is the most hype innovation?
Can we answer these questions or
yeah,
not?
you can answer.
Multiple choice.
Oh.
Yeah.
Okay.
I want to know when I should put my stock in.
Yeah, that's right.
It's a very ulterior motive on my side.
Some of these can overlap a bit, but that's fine.
Yeah. It's not like a serious polling. It's just a polling. All right, I'll give you 1 to the full minutes, and then we're going to start with the conference. Looks like we have a whole room and decent attendance. So, right, so and polls. So this is how it looks. So it looks like, COVID will survive. Looks like AI in genetic engineering and mRNA and nanotech. It looks the most hype is the same.
And mRNA.
Yeah, I don't know where I should put my money then. All right, so let's start the conference. It's time, and all the stragglers should join by now. So let me do this. Okay. All right. Thank you very much, everybody. My name is Chris Laudansky. I'm the president of the Society of Healthcare Innovation. And today I have a pleasure to open our conference. That's our first one. We're doing this for the 3 years. The conference Innovation Frontiers is designed to show what is way ahead of us, which the people may talk, but they don't talk about this in the CNN. So the idea is, what is the idea behind this year's conference is what are the unintended consequences of the innovation, not only good things, but the bad things. And the reason why we're having this conference in this particular format is because for the last 2 years, we partnered with the University of California, Santa Cruz, Crown College, which is one of the powerhouses of the ethical thinking. And one of our hosts, Linda, is actually one of our moderators. So again, University of California, Santa Cruz, Crown College is one of the leading sources of the information about the ethics in innovation and how the innovation should be responsible implemented. I represent Society of Healthcare Innovation, which is a band of the people who came together with the purpose of making the innovation accessible for other people, especially innovation in terms of the healthcare. So we're trying to make sure that when you hear innovation,
Chris?
Chris,
We lost you, Chris.
oh dear. Well,
So
let me go.
we lost you, Chris, for a little while.
okay.
Yeah.
So I'm sorry about that. It says my internet connection is unstable. But since you lost me, I think it's a good time for Gabriela to take over and present the speakers. Gabriela?
Yes. Hi, everyone. Happy to be here. And thank you, Chris and SHCI and the University of California, Santa Cruz. It is my pleasure to introduce our two speakers today, Catherine Myronic, who studied at the University of California, and she's currently working at Singularity University, and is a co-producer at Humanity Needs Dreamers, a science education nonprofit. Her talks encompass synthesis and foresight, the power of the beginner, and effective interdisciplinary teams, the failure modes of experts, and the complex factors affecting the future of jobs, the possibility of economic climate change as well. Leonard Peterson, he received his Master of Science from the London School of Economics and Political Science, and he has a bachelor's degree as well from the Copenhagen Business School. His professional interests include decentralized infrastructure of digital healthcare, dynamic consent, analysis of health data projects with public funding, and economics of health technology. So it's a pleasure to have you all here.
Thank you, Gabriela. So let me introduce our moderators. Both are my friends, so the presentation will be a little bit biased, but they both deserve all the credit. Gabriela has over 25 years experience in the innovation. She's passionate about the innovation. Her focus is about building the new value. She's currently working on the developing new models, and she's also a very well-known entrepreneur. She has at least 2 companies, and every time I have a question how to develop innovation, I go back to her. She also finished a degree at the University of Pennsylvania in the Master in the Healthcare Innovation. That's how we met. Linda is my another very good friend. We met, I don't remember how, a couple of years ago. But Linda is a lawyer who became very, very interested into the ethical aspects of the innovation. And that's how we were talking about responsible ethical development of the innovation. She's one of the board member and founder of the Turbo, and she's extremely well connected from the Silicon Valley. And a lot of speakers that we have at this conference is thanks to her. Now,
thanks, Chris. I just wanted to say MAC. The name was misspelled, but thank you. Glad to be here and glad to be a co-moderator. Thanks.
Thank you. Now, how do we access the conference? So again, thanks to Linda and our partnership with University of Santa Cruz, we have this design as actually streaming events. So we have from one side, we ask you people to sign for the conference, but we're also actively streaming on the YouTube, and that's a lot of your presentation go to the classroom at USC. Now, how this is going to work? We're going for the introduction. We're going to have 2 presentations side by side. We start from Leo. We move to the Catherine. Then Gabriela and Linda will do the honor to be a host. Then we will divide you into the break room. Our presenters or the moderators don't have to go to that room. This is the idea when the groups can sort of brainstorm the questions and maybe come with some of them, because after 10 minutes, I will pull you back and you don't need to worry about the timing. I will do it automatically. And then again, Linda and Gabriela will take over the process and have a conversation with our presenters. And then at 3:30, we will have a hard stop. Now, how this is supposed to work? So we all civil. So first of all, mute your audio. Make sure that the camera is looking on something decent behind you. And I would strongly suggest to mute you, especially if you're like me in the hospital and there's a lot of overhead pages. Be mindful of this background noise. There's not really much of the guidelines for the breakout rooms. Like, I assume everybody knows what the civil behavior is. It's probably nothing like the presidential debate last year, just much more coffee meeting. And please remember that all of this is Leo?
All right, it's my turn as far as I understand. I just
That's correct.
Two last words. All right. So first of all, I would like to thank the organizers for the invitation to speak at this conference, Innovation Frontiers 2022. I work at Copenhagen Institute for Future Studies at the health team. And I would like, first of all, to tell you just a couple of words about the Institute. It is more than 50 years old. Our founder, I have his picture right here. His name was Torkel Christensen. He was the head of OECD for many years, and following a series of meetings with John F. Kennedy, you can see it on this picture, he decided to basically to make this institute into a basically an institute to study possible scenarios for future development in various industries. So the we are about 30 in-house and about the same number of out-house futurists, economists, and other researchers. We engage with major Scandinavian, European, and global companies, government agencies, and international organizations to verify their long-term strategies against possible scenarios of future developments in their respective sectors and industries. This future-proofing is our core product, but we run quite a few other projects. In the health team, we are engaged with research and development of future visions and strategies in healthcare. Our core project is called Movement Health 2030. We operated in several countries in Latin America, Middle East, and Europe. Also, we have had a similar project in Canada. In these countries, we do roundtables where we invite representatives of main healthcare stakeholders, patient organizations, doctors, healthcare economists, other relevant experts, representatives of the healthcare industry, of regulators and government agencies engaged in healthcare. Together, we identify strengths and weaknesses of a national healthcare system with regards to a rollout of innovations, help arrive to a common vision. And when I mention the word common vision, that is basically how major stakeholders in any given country want their healthcare system to look like in 2030. And we identify innovation challenges and also suggest scalable pilot projects to address these challenges. We are involved in quite a few other projects than Movement Health 2030. Our most recent one, initiated last week, is developing a national strategy for life sciences in Finland. Now, what is blockchain, to the topic of my presentation? You know, when I was doing such presentations in 2016, 17, and 18, I started always with a very detailed explanation of what blockchain was, and I tried to employ all kinds of visual aids. Fortunately, this time passed. Now many more know what blockchain is. However, there are some concepts and terms in blockchain that I will go through now. Basically, these concepts are immutability, distributed verification, and smart contracts. And here if you look at what blockchain is, first of all, basically it is a decentralized database. They also call it a distributed ledger. Think of it as a database that exists in many computers. An important point is that it is not one database that can be accessed from these numerous computers. It is distributed. It means that identical copies of a database exist at all these computers that participate in a blockchain network. When one computer changes anything in this database, the changes automatically and immediately appear in all other computers connected to this network. In fact, when I talk about changes, it is a bit of a wrong term, because you cannot change anything in blockchain. It is an add-only database. Data in blockchain is organized into blocks, hence the name of a blockchain, a chain of blocks. When you delete anything in blockchain, what happens is that you create a new block that says, do not pay attention to that prior block anymore. But that deleted block is still there. The same goes for change of any data in any existing block. A new block in the chain is created that says, change that prior block, but the original unchanged block is still there. Perhaps the main point in a blockchain network is that any participant can make changes, add new blocks, do transactions, as they call it. There is no one commander, boss, director, or network administrator to approve the transactions. So how do we know that another participant tells the truth? What is the governance mechanism of blockchain? It is done via so-called proofs. In the oldest blockchain that you have probably all heard of, the blockchain of Bitcoin, they have so-called miners. These are the people who give the power of the computing power of their computers to confirm transactions in exchange of a chance to receive a bit of a newly minted Bitcoin. This is their reward for mining. Their computers check every transaction, look at digital wallets of senders and receivers to see if there are any issues. There are other governance mechanisms. There is other proofs. For example, proof of stake, like in the Ethereum blockchain. It is the second largest cryptocurrency after Bitcoin. In so-called private or corporate blockchains, other proofs may be used. For example, proof of origin. In blockchains that are used to certify the origin of a medical drug, they often use the proof of origin. It means that the right to verify a transaction is delegated to a particular group of computers, usually those that are in use by manufacturers of the drugs. Lastly, there is one more important concept. I will come back to it later, but I want to tell you about it now. It is a smart contract. A smart contract is really like a macro in Word. When you press Ctrl-B in Word, your selected text becomes bold. Now imagine that instead of the text becoming bold, there is a contract that executes itself when certain conditions are met. Say, for example, we want to trade coffee on blockchain. We write a code that will execute a command to buy a certain amount of coffee once its buying price with the coffee producers in any given country is lower than X. And to sell it once the retail price in another country exceeds Y. In fact, you can also add everything else to such a smart contract. For example, registration of the company, shipping arrangements, and deregistration of the company as well. Now, where blockchain is used in healthcare. On the next slide that I will show now, I have grouped blockchain adoptions with most notable projects in each group. Do not try to, well, first of all, I sent the slides to the slide deck to the organizers, so you will all have it, but I will be shifting back to it. Now, let me just show you. Right. Here it is. So, first of all, we have the drug traceability. And here the most notable projects are MediLedger, sub-blockchain for pharmaceuticals, PharmaTrust, and indeed the blockchain of Foods and Drugs Administration, as well as Consensus Health. Now, what is drug traceability and what blockchain can do about it? It is to secure supply chain and drug traceability, basically. By using blockchain to secure the supply chain for medical products, producers and distributors ensure that they are safe and are not counterfeit. Smart contracts and unique identifiers in the blockchain ensure also that practitioners give the correct patient the right drug. In drug traceability, secure supply chain tracking is necessary to prevent the distribution of counterfeit or illicit drugs. In order to address illegal transport or unauthorized production of controlled substances, blockchain technology presents the opportunity to securely track, indicate chronology, and highlight identifying data, makeup, and composition of substances in an immutable record. Blockchain-based drug supply chain management becomes more secure and accountable with transparency, immutability, and the interoperability that is introduced by blockchain. The interoperability between networks ensures that different blockchain applications and systems along the supply chain can interact coherently. Therefore, pharmaceutical companies can register their products on the blockchain and track movements from source point right to the end consumer. The next point is secure management of electronic health records. Here, perhaps the most notable projects are medical chain and prescriptor. By the way, most of the, if not all, projects that I mentioned here are based in the United States. The blockchain can do wonders for electronic health records. In the recent years, the healthcare industry experienced more cybersecurity breaches than any other industry. The number is expected to rise. Through blockchain services, patients can take control of their records. Smart contracts release medical records to approved healthcare professionals through their mobile devices. Other blockchain technologies store encrypted patient records in hospitals, storing only the permissions for the data on the blockchain, not the data itself. Blockchain enables secure and structured data sharing among the medical community through decentralized databases. These structures work to protect patient and data and privacy, and also allow doctors visibility over their patients' medical histories, as well as they empower researchers to use shared data to propel scientific progress. The blockchain solutions enable structured data ownership through privacy and permission layers built on a public blockchain, or by employing a permissioned blockchain frameworks from the start. While patients are unable to change or delete specific medical information input by doctors into their profiles, they can control access by granting full or partial visibility to various stakeholders in the healthcare system. For example, patients may share full records with a medical specialist, but may choose to share only non-identifiable data with scientific research firms or other larger healthcare organizations. The next point, the next group of blockchain adoptions is data accessibility in clinical trials and other research projects. Here we have such projects as Clinical Supply Blockchain Working Group, the Medical DAO, which is a very big project indeed, as well as Pharmaceutical User Software Exchange. In clinical trials, basically the blockchain is used to ensure seamless and secure sharing of medical records between medical professionals. Many researchers cannot obtain enough data to perform an accurate study. Additionally, clinical trials can struggle to find patients, and trial results are sometimes faked to get products to the market more quickly. To accelerate the process of acquiring patients and data for trials or studies, blockchain solutions are employed. Blockchain is also used to verify credentials of healthcare professionals. Blockchain adoption reduces the risk of data fraud with its consensus mechanism and decentralized structures that guards against hacks or manipulation. Documents may be given proof of existence or verification of authenticity on the blockchain. The majority of nodes that reach consensus to approve new transactions and to prevent modification of the data. This protects the integrity of data and promotes trustworthy trial results, as well as it encourages collaboration among among the research community. The next group of blockchain adoptions is patient engagement. And here, let me just come back to the slide again. Here, perhaps the most notable projects are Virta Health, it's based in California, Arizona Care Network, IQ, also Californian, Mint Health, and Health Rewards Platform, both American. So what is it about blockchain and patient engagement? It is about reward tokens. These projects basically aim to reward patients to transition to healthy lifestyles, as well as to ensure regular health checkups. Smart contracts on blockchain enable the introduction of micropayments to incentivize specific patient behavior. These contracts can be programmed to release rewards to patients for following a certain treatment plan or sharing their data for clinical research. The next one, well, the next group is blockchain consortia. And here we have quite a few projects. One of the, perhaps one of the most interesting group of projects is called Hyperledger. It's one of the largest private blockchains, the corporate blockchains. And I have been for years a member of their special interest group on healthcare. But there are other projects, quite a few of them. And well, I have listed them all here. The medical chain is a very interesting one to look at, as well as the DocChain Alliance. The blockchain consortia is about partnerships. It is partnerships between major blockchain developers and firms in the healthcare sector. Such projects aim to bring innovations to the healthcare sector to empower health and life quality of individuals and communities with benefits of distributed ledger technologies, and to reduce administrative costs in the healthcare sector. Another type of consortium that may invite several major healthcare service providers to use one particular blockchain standard aims to solve interoperability issues between various blockchain protocols. Now let's talk about the ethical issues to address blockchain. Blockchain adoption is, of course, rapidly growing in the healthcare sector. Therefore, it is important to consider potential consequences and ethical implications of such adoptions. Like other high tech in healthcare, such as artificial intelligence, machine learning, and robotics, decentralized technologies pose very complex ethical questions. And I'm going to basically mention three, well, major ones, from my point of view. One of them is ethical design. The next one is the right to be forgotten. And the third one bears the terrible name of algocracy. It is a very interesting area, algocracy. That's why I want to finish with it. Now, the ethical design. We are, of course, talking about architectural, the IT architecture, the design of a network. The concept of ethics by design examines how ethical concerns can be incorporated into a network design in order to ensure that the healthcare provider takes patients' preferences seriously. An ethical design has to go beyond regulations. A framework for ethical design usually includes ethical principles to follow. organizational values, risk mitigation strategies, privacy and security policies, as well as policies on sustainability. And they may vary greatly depending on the open, public versus closed or corporate blockchain. An example of an open blockchain is the blockchain of Bitcoin. An example of a corporate blockchain is Hyperledger. Healthcare blockchains may require an analysis of ethical frameworks that govern them before they can have intended impact in the healthcare ecosystem. Therefore, the European Union, specifically its blockchain observatory, recommends that legislators and regulators of the member states review ethical frameworks for healthcare blockchain. This will enable them to make informed decisions about how blockchains will impact the European healthcare ecosystem. The next point is the right to be forgotten. I told you that a block cannot be removed from a blockchain. Any removal is simply creation of yet another block that specifies not to use a particular prior block. But this prior block still remains in the blockchain, even if it is rendered invisible or out of use. Data in a blockchain cannot be deleted due to the add-only nature of this distributed ledger. This poses a threat to individual privacy, namely to the right to be forgotten. The right to be forgotten is not just a fine concept. It is a requirement of the General Data Protection Law, the European analog of California Consumer Protection Law, or other data protection acts adopted in the United States. At present, there is no universal solution to this collision between the immutability of blockchain and the right to be forgotten. However, there are individual solutions. Even the very first blockchain, the blockchain of Bitcoin, had, according to its mysterious founder, Satoshi Nakamoto, some technical means to delete data to save disk space. Other solutions are federated blockchains, also known as consortium blockchains, where privileged participants may hide data from other participants. Not that it sounds very ethical. There have been other attempts to design blockchains to make them GDPR compatible. Also, the right to be forgotten is not absolute. The Article 17 of the European General Data Protection Regulation defines circumstances when the right to be forgotten may be waived. And now we arrive to algocracy. So algocracy is a concept that refers to algorithmic decision-making. Many blockchain proponents believe that problems we face as humans can be solved by moving decision-making away from humans and into machine learning black boxes. I understand these arguments. I mean, have a look around at the current state of affairs worldwide, and obviously we humans do not excel in decision-making. However, we design algorithms, and I'm sure you have all heard of AI bias. Surely a blockchain bias is possible as well. One solution is that ethical guidelines for medical blockchains should be based on established guidelines and recommendations in the field of artificial intelligence. I would like to conclude with the following. Blockchain technology's ethical issues are the result of its three main promises: immutability, distributed verification, and automation. As a result of immutability, human past records remain permanent, posing ethical concerns on privacy and transparency. In distributed verification, a large number of stakeholders are involved in verifying outcomes. Accountability and equal opportunity are the ethical issues raised by distributed verification. Automation in the blockchain context refers mainly to smart contracts and to the fact that most decisions on blockchain, most transactions on blockchain are approved automatically. The smart contracts, as we mentioned before, are the coded agreements, and they include self-executing features, which raises human dignity issues, among other concerns, in the healthcare context. And that's what I wanted to tell you in my presentation. Back to you guys. I will be, of course, happy to answer questions.
Thank you, Leo. That was fantastic.
You can move to Catherine now.
All right. Hello, everybody, and thank you for this opportunity to talk about innovation and healthcare, with specifically looking at blockchain. And I would like to introduce myself a little bit. My name is Catherine Myronic. I have been in Silicon Valley for the past more than 2 decades, and I've had the opportunity to work with innovators across a wide varieties of fields. Now, I'm going to get to talking about blockchain, but I want to go over 3 concept sets which I think are very important to understand ahead of talking about blockchain itself, which are exponential technologies, convergence, which is the intersection of technologies or the intersection of areas, and then something specifically about expertise, which is what I call the failure modes of experts and the failure modes of smart people. Because when we're talking about technologies, we're never talking about just the technology, we're talking about who is using it. So let me get right into this. So when we talk about exponentials, exponential can have a specific mathematical meaning, or it can mean sort of a metaphorical sense. It can mean specifically Moore's law and the change of the computing power, but it also means a large set of other technologies as well. And Silicon Valley and the wider world of innovation all around the world is filled with aspects of exponential growth. For example, you have the people who start new trends, like the person who helped start and helped create the very first cell phone, leading to the world we have today, a world where billions of people are connected together. You have the people who are working in innovation, specifically in healthcare, such as Dr. Catherine Moore of Intuitive Surgical, who has been working for years on how to bring the convergence of robotics and healthcare together to give surgeons and others better abilities and better capabilities as they are doing surgery. And then, of course, and startup culture exemplifies this, you have the people who are launching the new companies and new ideas. And as I've been working with them, I have been able to see patterns of what works well and what sometimes doesn't work well when people are doing innovation and when people are doing startups. And in the big picture, a lot of times these new technologies can intimidate people. And that is something that I do not like. My framing analogy for almost all of these is saying is you do not need to be able to build a car to be able to drive a car. Unless, of course, you were just starting out. And 130, 140 years ago, yes, you did need to know how to be able to... Okay, just a moment. There's an earthquake. I'm going to sit still, but I might have to jump off this call. I apologize. This looks like a large earthquake.
Okay.
I think it's over.
It's called
Yeah, I'm feeling it too.
Well, actually, I was...
Well, take the moment and make sure that we are good. Okay.
Yes.
Well, all right. So I have to tell you. So a few years ago, I was going to be did give a talk in New Zealand, and the day before the talk, the day before the conference opened, there was a 7.8 earthquake in there, and I was in Christchurch. And so ever since then, even a small earthquake will certainly set my my nerves a-going.
Well, I have to admit that I thought that maybe Leo will be in trouble because he's in Georgia next to Russia, but obviously California seems to be more dangerous than Georgia.
Well, all right. I'm going to keep on going, but if there's a larger earthquake again, you might suddenly see me disappear off. And this is there's something ironic about all this, and I'll get to it. Anyways, yes, you don't have to be able to build a car to be able to drive a car, other than when the technology of cars had just launched, and then it really helped to be able to do so. And you don't need to be able to even drive a car to be able to talk about the future of technology. But to be able to talk about cars, you would need to know about their capabilities, limitations, and trends, even if you don't drive them, even if you can't build them. And my argument is that all technologies are the same way. And when we talk about exponentials, of course, we're thinking about computers, but exponential trends are in multiple areas. For example, you think about satellites that at one point were only in the domain of the largest governments and the largest companies and would cost $500 million. And then you have companies like Planet, the founders of which I happen to know, who are now, creating a world where satellites cost, instead of $500 million, they cost $500,000, and that price keeps on dropping. I believe it's now under $150,000. Similarly, when you think about things like underwater exploration, submarines used to be, first of all, in the domain of governments and militaries, and then Jacques Cousteau. But now here's a picture that I took from the Maker Faire of high schoolers who are using open source software to be able to build robots. And my argument here is to be able to say that a lot of times technology, it's very exciting when it's first announced, but when it becomes a commodity, when it becomes something which is not in the hands of people only with PhDs, but in the hands of high schoolers, that's when it becomes really interesting. It might seem boring and ordinary, but because it's no longer 100 people deciding how to use it, but millions of people or billions of people, you have an incredible outpouring of creativity and uses. And as I say, it is computing. It is multiple other areas: robotics, nanotechnology, genetics and genomics. All of these areas have exponential components to it. It's not just about that the price has dropped or that there's many more available, but also that it's gone from, say, the first few computers using the first few computers, in other words, the people doing computing, using the first few digital computers, to billions of people having access to this. Now, I also mentioned convergence, and this is the area that I work on, because you have the technologies, but the technologies both come into existence and are used by many people when you have multiple areas coming together. Because you think about mobile technologies, what happens if you take a mobile phone and you give it the ability to move around, like you put wheels on it? What happens if you have a mobile phone and you converge it with another technology like solar? And of course, sensors are a type of exponential change, and also connectivity in how we work with each other. So for example, the combination of, what if you have mobile technology and volunteers? And, so going back to, open source robotics projects, something like OpenROV in many ways is like taking a cell phone and allowing it to be able to move about. Using technologies which are developed in other areas, for example, in communications, and combining them to be able to give new capabilities, of course, to high schoolers, but then to anybody else who might need it. Say, for example, if you had a government which did not want people to be able to measure pollution in the water, projects like OpenROV and others allow people to be able to say, well, look, can I take a sensor? Can I put it on the device? Can I send it out? We've certainly seen this with things like pollution, with air pollution sensing, where now millions of people around the world have volunteered to be able to put sensors into their own houses. And so that even if a government doesn't want to be able to report on environmental pollution, people themselves are able to do that. Going back to these small satellite projects, the planet system really was taking a cell phone, of course, making sure it's space hardened, and being able to put it into space. So it was a new attitude towards how can you have sensing in space? How can you have new types of connectivity? Another things that happens with these technologies is that when they are first launched, sometimes they are launched in some sense for entertainment. The very first webcam, as we would consider it today, was a camera pointed at a coffee pot, so you could know if the coffee pot was full or not. And of course, you'd say, well, look, you could just go look at it. What's the purpose of this? But now, of course, webcams are used for millions of purposes, including, for example, this is a project that I know the founders of, being able to, if a person who is visually impaired needs to be able to see, an object, they can use their phone and be able to, just a moment, I'm being informed that that earthquake was a 5.0, but it was very close, which makes them feel a lot more powerful. Anyways, being able to ask volunteers to come along and if you need to be able to see what you're looking at, what is this food product in front of me, what is this book, you can use your phone and get a picture of it, and the volunteer tells you what it is.
Mm-hmm.
And of course, you have things like virtual reality, which start off being used for military and large industrial applications and is used for games, but also is being used for things like education. Here is somebody that I know who's founded 360 Education, and they are using virtual reality for example, for projects like teacher training in areas where it's very difficult and expensive to be able to bring in teachers. But being able to show an active education in virtual reality, the teacher is able to learn the teacher in training is able to learn about, good ways to be able to interact with the classroom. And there's really no substitute for this. You could try to read about it, you could try to watch a video about it, but a fixed camera view doesn't give you the same view as VR, where you can watch a scene once, what the teacher is doing, and watch the scene again, and what the learners are doing. Now, another thing about exponentials, though, that I want to talk about is that they can surprise people. So here, for example, is Dr. Daniel Kahneman. We all know him to be a very smart person. And 2 years ago, I got to ask him in an interview that was being done. It was about June of 2020. And I said, Dr. Kahneman, what happened when sorry, I'm still a little bit shaken. Dr. Kahneman, what happened when COVID first started out that surprised you? It could be about response, it could be about yourself. And he said, yeah, let me tell you, when COVID happened, I surprised myself, he said. I was on an airplane reading an article about COVID in France, and I saw the article saying that there's going to be 100 people, that there were 100 people, 100 detected cases there in France. And I read that and I thought, well, nothing at all. I didn't get worried about it. I just said, oh, that's interesting. And he said, in retrospect, of course, if you have 100 cases can rapidly become 200, become 800, become 1,000, become 2,000, which of course is what was happening in France. And he said, in retrospect, when I read about 100 cases, I should have been quite worried about it. But all of that to say that even smart people, even people who are really used to a particular type of exponential, can still be surprised by exponentials. Now, another thing that happens, and yes, I gave this example before, put this up there before today just happened, which is that 2 years ago, I was quite excited to get an alert on my cell phone about a earthquake that was happening, in this case, 360 kilometers away on the other side of the mountains. And I was very happy to see this because we need to have this. This is a useful thing to be able to do. Because even though the earthquake is sweeping towards you at 12,000 kilometers an hour, over 8,000 miles an hour, if you're more than a few miles away, which just now we weren't, you can have several seconds of warning before it hits. And that's really amazing, and that's really good. And this happened in California in 2020. The problem was, of course, is that if you go back and look at the warning system in Japan, Japan has had an earthquake early warning system like this for, since 2007. Mexico City has had earthquake, and parts of Mexico have had earthquake early warning systems for much longer than that. So why is it that a system which is desirable and demonstrated and done and completed in other countries was not available in California, was not available even in Silicon Valley? And there's many reasons there's many reasons why this happened. It's one of the big arguments. It's just technology is not enough. The existence of the technology is not enough to ensure that it happens. And why is this? It really comes down to people and the decisions that they make. Now, going back to this idea that you don't need to be able to build a car to be able to drive a car, if you went to a conference on cars without the ability to build a car, without the ability to drive a car, people might look at you a little bit funny. You'd be able to say, like, what are you doing here? And I think we've all been in that experience where we don't have the vocabulary of the experts around us. And I want to talk about expertise. I'm going to use an analogy here. We've all heard this story that if a person is lost in the woods without being able to see the sky without a GPS, or if you're lost in the snow and again you're not able to see a distant object, you're going to walk in circles. We've all heard this. And scientists have tested this, and this ends up being true. That even people who are like orienteers, people who are experts at getting from point A to point B, in this case that they're blindfolded, in other cases we've seen it if you can't see very far, they say they believe that they're walking in a straight line. They're not. They end up going in a circle. There's multiple reasons for this, but one of which is simply that if there's even the slightest difference in your gait, left foot to right foot, that you'll start leaning in a particular direction, and this tiny little lean after 1,000 steps adds up. And with expertise, I want to use this as a framing analogy, because think about the difference between using your own kitchen and using somebody else's kitchen. Think about the difference between using your own workshop and using somebody else's workshop. Using your own kitchen where everything is set up exactly where you want it to be, using your own workshop where you don't even have to look to know where a particular tool is, that's very comfortable. You're able to do what you want to do almost without thinking about it. You're able to do the system one thinking, as Daniel Kahneman wrote about. Using somebody else's system, that's discomfortable. It's slow. So given a choice between what you're going to use, I think you're going to lean towards what you know and what you like. I think that if you're lost in the woods and you've got a GPS, you're going to walk in a straight line. But the moment you say, I'm now an expert at walking in a straight line, I don't need any outside tools, you're going to go back to walking in a circle. Expertise, I believe, is similar. That if you have tools which allow you to be able to get outside of what you're comfortable with, get outside of the tools that you're used to, you will be able to do so. But the moment you say, oh, I'm now an expert at thinking outside of my own head, I'm now an expert at being able to bring in outside views, outside people, you're going to start leaning back towards what you like to do, what you're good at doing, the people that you know. And so using that as a framing analogy, I want to talk a little bit more about sort of the strengths and weaknesses of expertise. For example, going back to the idea of satellites, this picture is of the NASA Small Satellite Program, and here they are building smaller satellites. Instead of satellites being the size of school buses, here we have satellites which are the size of washing machines. And shrinking them that way, shrinking them by 50%, shrinking them by 75%, reducing the price by 10% or 20% or 90% is pretty good. But what Planet was able to do by saying, we're not just going to take a large thing and shrink it, we're going to be able to take a small thing and be able to make it just slightly larger, is a very large twist, being able to get something which is not, just 10% less expensive or 50% less expensive, but 99% less expensive. That took some outside thinking. Experts can be limited by their imagination or by their expertise. Another thing that can happen is that, say here's an example where I was giving a talk to a group of experts on energy systems and energy innovation, and I could have come to them and given them 50 examples of startup in energy. But what was going to happen is there's going to be somebody, that expert in the front row, who's going to listen to me saying, well, here's an example, and here's an example of a startup. And they're going to say, well, fine, but 45 out of those 50 startups are going to die. They're not going to work out. So why are you giving us these examples? And they would be right. Most of these projects are going to fail. And there's many lessons to be learned from when you're talking as an outsider to other people, but many times you learn experts don't necessarily want to hear about themselves from others, because others are going to come in with a naive viewpoint. Now here's another analogy I want to give. Think about a researcher who's about to do an experiment, and before they do the experiment, they know the answer they're going to get. Are they doing an experiment? I would say no. They are doing a demonstration, and there's good reasons for doing demonstrations, but you're not going to be pushing the boundaries of knowledge if you know exactly the result you're going to get before you do it. Now imagine somebody's about to ask a question, and before they ask the question, they know the result they're going to get. they know what the answer is already. Are they asking a question? I will argue no. They're doing a demonstration. And many times when people are asking questions, like for example, when I was asking a question of Dr. Daniel Kahneman, it can be difficult to ask a question if you don't know what the answer is going to be. Now, going back to Dr. Daniel Kahneman and the example that he gave about he missed an exponential, he is a person who wrote a book about thinking fast and slow and how you can't just jump into your, whatever you're thinking right away, that you have to think about, might I be missing something if I'm feeling comfortable with these numbers? One of the things that happens is many times experts, smart people, forget that you can make major mistakes, that you can forget to use tools, that Daniel Kahneman forgot to use his method on himself. I think this just tells us that anybody is capable of doing this. Now, going back to this example of the energy experts, where I could have given them a bunch of examples of energy startups, and they would have said most of them are going to fail, I decided, I'm not going to give them examples of energy. I gave them examples of space startups, where all around the world, today over 100 countries have space agencies. You have companies like Planet and many others who are building tools, and not only building these tools, but giving capabilities, for example, rapid sensors, to people who previously didn't have it, because the less expensive satellites also means the images themselves are less expensive. Being able to see something changing day by day is less expensive. And by giving them examples of space, because space is an area which used to have, as I said, only large companies and large countries being able to do it, and now it's something in the hand of innovators, why wouldn't energy also have the same capabilities? And why wouldn't innovation in energy have the same growth? Because if energy experts don't want to hear about themselves from outsiders, well, you don't talk about them, you talk about other areas, and they have to make their own conclusions about what is possible. Another thing, of course, that happens is that experts are deeply aware of why things haven't worked previously. If you ask experts in the Sustainable Development Goals about are they going to happen in time, they're going to be able to look back and say, well, look at the Millennium Development Goals previously and what happened with those. They didn't always happen. This stuff is difficult. And ways of dealing this, of course, is being able to say that, if you believe that something is or isn't possible, have you tested that? For example, if you believe that you as an expert, as a group as an expert, have all the best answers, set it up as a contest. Go out and ask others. For example, here's a contest from over 10 years ago where physicists were saying, we think that we know the best algorithm for solving a particular problem, but let's see how everybody else does. And a PhD student, a glaciologist, came in and came with a better answer for them. So I don't say that they were all certain that they knew the best answer, but by opening it up to others, they were able to bring in new ideas. As I say, experts think that they will know who needs to be in the room and what works and what doesn't work, and it takes practice to be able to do otherwise. So, for example, a number of years ago, when Ebola, and again, once it's coming out, experts were saying, look, we have a bunch of ideas how to work on it, including things like the protective suit, but let's open it up. Let's see if other people can come up with good ideas. And the team that has come up with a better idea for changing suits included a wedding dress designer who also did costume design. This is an area where as soon as I say that, you're saying, aha, somebody who is an expert, not in hazard suits, but in how to be able to change a suit, how do suits fit on the body, will be able to help a team. This is obvious in retrospect, but not necessarily before it's done. Another thing that happens when we talk about change in expertise is that we see these projects in retrospect, and we have to look at them as they're happening. For example, Moore's Law itself was started because a group of people, the 8 people, including Gordon Moore of Moore's Law, got together to work on new technologies. They brought in diverse skills. They brought in tools from multiple fields, and they created a culture of innovation. And at the time that it was happening, it was a desperate marketing decision, what we call Moore's Law today. But, and in retrospect it feels so inevitable, at the time they could have gone bankrupt, but they didn't. The other thing that happens, of course, is that when you have something like Moore's law, which is a decision that people make, it's a tool. It's not like a law of nature, is that Moore's law can be picked up and borrowed by other fields. Here, for example, the carbon law project, where people are deciding, let's give industries the opportunity to announce that they're going to drop their carbon in half and reduce the carbon cost of what they're doing, very similar to Moore's law. So, to talk about expertise again, is many times experts know who needs to be in the room, or they have a sense of what works and what doesn't work. These are all testable hypotheses, and we have to learn from acts where people have in fact tested these, where you add more people, you add more rooms, you have how versus why conversations, you use other tools to be able to get around the limitations of expertise. So now to go into blockchain and to talk about blockchain, and I said earlier that you have many 30, 40, 50-year-old technologies which are now getting interesting because they are easier to use, they're more distributed, like these technologies. Blockchain itself is now a 40-year-old technology. We get surprised by this. But here's a dissertation that David Chaum did back in 1982, how to be able to set up a system where you have a group, in his case, a group of organizations who don't necessarily trust one another, that they can build a system together where the information within it is something that they can trust. And this is at heart what blockchain is all about, what you are learning about. Can you build a system where groups of people who, well, they might be able to trust each other, but as you're bringing more and more people into the system, how do you know that what you have in there is a trustable set of systems? And they were able to do this. What Chaum did and what other people built on it over the years. This is not something that just emerged with Bitcoin back in 2009. There's a long history of it, people being able to say, can we build a system, a distributed system, a peer-to-peer system, where what was once centralized is now in the hands of many other people? What was limited by the imagination of just whatever company owned it can instead be something where multiple people can work on it, multiple groups can work on it. Now, of course, we know about all of the applications that we have, cryptocurrencies, smart contracts, NFTs, distributed autonomous organizations, which have been made possible by the convergence of these underlying technologies with goals that we have. Now, going back to the example of, what are webcams and how can technologies which are originally developed for one purpose be used by others and be used by volunteers, this is what we've seen with the technology of blockchain. So, for example, last year, you probably saw the example of a copy of the Constitution being up and available for sale, and a group of people said, look, it may be the case that a very rich individual is going to buy this, it might be able to put aside. Can we create an organization very quickly? And it happened within a few days of an organization getting together, a group of people getting together and coming up with a rule for how to put money in and to be able to buy this. Now, this example of a group coming together to buy the Constitution, is this the sort of example which we're able to say, well, is this meaningful? Is this important? Yes, it is, both in and of itself, but as an example of, hey, we are now in the world where people can get together very quickly and start doing activities. People can get together and come up with a self-organizing system and have a set of rules. So when we look at blockchain and healthcare and these applications, all of the applications that we're talking about today, first of all, these are still very early examples of what we're able to do. When we look at, the first 10 or 20 years of what we were doing with cell phones, the first 10 or 20 years of what we're doing with the multiple set of technologies, yeah, they were early, they were incomplete, but people are able to use these version 1s of technologies to be able to start building new technologies. So all of these that we're talking about today, these are useful, they are early, they are incomplete, but when we're talking about innovation, we have to be able to say, can we learn from innovation in other areas where things start off incomplete, they start off looking almost useless, and be able to say, why do they need to exist? One of the things that happens, for example, with blockchain and Bitcoin is people say, well, look, when people are using it, they're using it for all sorts of nefarious purposes, or they're using it for useless purposes. Why do we need to have this? And of course, one of the problems that happens is that when we're looking at a particular technology and looking at everything that goes wrong with it, we're not saying, well, look at what's going wrong with the status quo today. You know, you can pull up a bunch of examples of odd things happening in the world of blockchain and Bitcoin and all the rest of them. But then when you just look at the ordinary healthcare system, we also see it there. And unless we're able to say and put these, side by side, unless we're able to say, let us judge the status quo as if it were the proposal, because when we're looking at the proposals for why we're using blockchain, we should be saying to ourselves, if we need these to happen, do we need these to happen? Well, yes, because the status quo itself has a lot of problems today. So all of these areas of blockchain application and innovation, we have to be able to do a couple of things. We have to be able to say, what is the nature of innovation and applications, and what happens when we have people dismissing a technology, saying like, oh, it's not useful yet. It's true. Many technologies start off like that. Oh, there's a lot of startups, and most of these startups are going to fail, and they're being done by naive people. Yes, that is absolutely true. However, first of all, the need for these sorts of innovation in healthcare are still immense. Fraudulence is happening today. The amount of research that is happening today and the way funding gets to particular projects is still highly centralized, and we have new systems to be able to decentralize it. It might not be blockchain necessarily, but just as cell phones allowed a group like Be My Eyes to be able to say, well, look, we're able to bring people together, we're able to bring volunteers together. You could try to use AI to be able to solve the problem of object recognition, but let's just bring people together to solve it. Similarly, if people are saying, look, blockchain is one way to be able to have distributed, decentralized systems, what are other ways we might be able to do that? So blockchain is both good in itself, but also as a way to inspire us to be able to say, let's just simply get away from what was before. So yes, there's deep implications of blockchain. There's ethical implications of blockchain, but of course there's just as large implications of not using blockchain. So I would really like to use this as a starting point to be able to talk about these. And so I would like to go into any sort of Q&A about the nature of innovation and blockchain and how people might be able to use it today. All right, thank you.
Thank you, Catherine. That was fantastic and so informative. Both myself and Gabriella are moderators. Gabriella, I have a few questions, but why don't we start out with one of yours?
One of mine. Okay, there's someone there has been some conversation in the chat here to everyone by Noel Kim. And so the question here is, or the comment here is, I thought, Noel Kim thought that blockchain was slower and potentially less secure. And Lisa agreed with indeed. So the question here is how do we ensure, speed in blockchain as applied? I think this question came through during Leo's presentation more, but it talks to how this technology at the end evolves and it gets faster, and at the same time layer the underlying layers are more developed and can upload or onboard massively more people in a simpler way, I guess. And they talked as also security as a, which I'm not sure, perhaps Nokim can expand on that, but that is the question.
If I can also add on to part of that, as part of the question, does this relate to the environmental impact too?
Okay.
Yeah, but Catherine and Leo, for either of you. I'm not seeing Leo on the screen though. Leo, you there?
Who shall start? I'm here. Can you hear me?
Why don't we go ahead and start with you, Leo?
Sure. When they talk about speed of blockchain, they usually compare. Well, they have been comparing it for years with the number of transactions done by Visa, and this threshold, I think it was 45,000 transactions per second. It has been long overcome. I mean, yes, it is indeed right that the first popular blockchains, like the blockchains that were designed for cryptocurrencies, at least the first ones, the Bitcoin and Ethereum, and Litecoin and others, they were slower, but the corporate blockchains like Hyperledger and quite a few others, even public blockchains like Solana, the latest ones, they are much quicker than Visa can ever imagine. About security, it is a very big subject. I just don't know how much time we have. It's in short, if in short, any public blockchain is less secure than any corporate blockchain. I know that proponents of cryptocurrencies will now probably jump and kill me for these words, but it's true. It's it's also important to stress that blockchains are used, in fact, in healthcare to ensure security, and the main concept is that on blockchain you can store only hashes of the data, only the indicators of the data, not the data itself, which of course makes it much more secure. And now over to Catherine, I believe.
Catherine.
Yeah, so this is an area I have a few times done work for or working with companies involved in the security industry. And so I've seen some mistakes or patterns in what people do, which again, I can call it the failure modes of experts. One of which, for example, is that, and I've seen it, which is that you have a company which is developing a security product, and they say, we've tested it, we know that it is, unbreakable. And I ask, well, how did you test it? And they said, well, our 20 engineers spent a month, trying to break it, and we didn't. And all right, that's an interesting approach, and a lot of times people do that. We think we can think of everything, and nowadays, I mean, this is years ago. Nowadays, people tend to say, like, okay, if we think we've got it, let's put it out there. Let's have a contest. Let's, either put a reward out there for how to, if somebody finds, somebody's able to break into it. If somebody finds a bug, we'll give them a reward. We'll test our assumption that we've thought of everything by giving it to everybody else to see what they've done. So when you talk about security in healthcare systems, so again, one of which the status quo itself can have a lot of problems. One, two, when you have original implementations using blockchain or using anything else, a lot of times the original people didn't think of everything. But once you get it out there, and especially when it's an open source system, other people, the purpose of version 1 of anything pretty much is to inspire other people to do it well. And so other people are able to come along and be able to say, look, I see your limitations. I see your goals are good. I see that this is now a solvable problem. It's a doable problem. Gee, what you did it originally is not so good, but we're going to try it again. So you have this ongoing evolution. And, again, using, in the nature of innovation and the process of innovation, usually the first replacement for something is really bad. You know, it's like instead, like you have these giant computers, and then the first computers, for like home computers, are pretty horrible, and there's not a lot of software for it. But because you have this proof of concept, because then you've got this process of people building on it and building on it, the thing that started off, you know, just like one minor change different from the previous status quo suddenly becomes much better on many different levels. When we're now that healthcare experts have been able to see, hey, we have a set of technologies. You don't simply have to do only what we were doing previously. The combination of experts are saying, well, we definitely have a need to be able to have more flexibility or more portability in electronic healthcare records, mixed with the security experts saying, look, and privacy experts also being able to say, look, here's things you have to be able to do. All these groups together build new systems which have capabilities that, you know, the previous single, centralized, hierarchical, limited number of people working on its systems aren't necessarily able to overcome or didn't even believe could be overcome.
Catherine, your entire presentation reminded me of Isaiah Berlin's essay about the fox and the hedgehog. That is that, you know, experts, are you a fox or a hedgehog? Because the fox knows many things, but the hedgehog knows one true thing, and the experts are the hedgehogs. So it's certainly a great call to an interdisciplinary discussion and having many different point of views. In a practical case, in a practical matter, one thing that has come up is right now with blockchain and healthcare records specifically, blockchain helps protect the privacy of healthcare records. So in the United States, we have HIPAA. In Europe, we have the, I always have trouble with the initials there.
GDPR.
GDPR.
Thank you, GDPR. Thank you. What about if people say, I want to sell my health information? Or in a similar manner, if you have a smartwatch, do you think like Apple Watch or, you know, any of the smartwatches could use blockchain, but then would they allow access to the creator of the data, so to speak? Do you see that as a potential upcoming issue?
There are a couple of large projects, notably one by Nokia, that aim to create a market of health information, health data. Also, we at the Institute are involved in a project called Phase 5, which is, well, pretty much about not just, well, it's not about selling the data, but it's about giving it up in exchange for rewards. Really, the sort of the main obstacle in the way of such projects is that the European legislation, in contrast to the American legislation, does not allow rewards for healthcare data. In Europe, you cannot legally give away your health data. Basically, healthcare providers cannot reward patients for anything. There are, you know, they allow only what they call insignificant gifts with no further explanation of what it is. And
but like Apple Watch is not a healthcare provider, but it can get the data.
Well,
I'm sorry. Go ahead, Catherine, please.
So, I mean, there's many, I think, you know, profound ethical issues having to do with this area, and one of which I, you know, say again is that there's you always have to talk about, you know, what are the dangers of doing nothing. Yeah. So, for example, one of the things that we've seen when you've got medical studies, and a problem that's come up is that, say, you have a group of people and they're participating in a medical trial for some purpose, and some of their data is there, and they gave permission for what can be used and can be not used. But say, for example, it's a medical trial and the medicine doesn't seem to be working for most people, but there's a small group for whom it works quite well. And the researchers now want to be able to say, what is there a genetic component? There's, what is the thing that makes it work quite well for this one group? There have been examples where they did not get permission to be able to go back and do this, and to be able to say combine the genetic data, or to be able to combine their trial with a different trial. And so in some sense, I mean, if a disease could be cured, a medicine can work on it, and the data's right there, but you can't use it, oh, that hurts. If instead you've got something like the blockchain where the data is out there, and you've got something like smart contracts, where people are able to say ahead of time, here are situations in which I want my data to be able to be used, then, or, here's a way that perhaps, and again, securely and safely and with privacy, you can come back and contact me and I can set things up so I can release a new set of data to you. You create a system where data which is used for one purpose can safely and securely be used for other purposes, which means that things move just that much faster. And something like the blockchain, or the grandchildren and the great-grandchildren of blockchain, because again, people are going to use these capabilities and be able to say, if these capabilities exist and are desirable, how are other ways that I can get this into the world? And people are continuing to do this, then people will be able to start saying, like, okay, what can we do to preserve privacy while rapidly expanding access to data? We've also starting to see that, where you get patients working together and being able to say, look, there's 1,000 of us with this orphan disease, and right now nothing's being done about it. Can we create an organization together? And distributed autonomous organization is one way of doing it. There's been others, but simply the idea of being able to say, like, oh wait, I can be empowered myself to be able to take my data, combine it with other data. We can raise, certainly they've been used, medical DAOs, to be able to raise money and start doing research. So how we do this exactly, of course, it requires this convergence of people from privacy fields, from security fields, from healthcare fields. But does this need to happen? It needs to happen, absolutely, because the alternative is sticking with the status quo with all of the problems which it has today. And again, sometimes we don't even see these problems as problems. We just say, well, just that's the way it is. Of course, you can't do anything about it. But the purpose of these original versions in early healthcare blockchain applications is to get to be able to say, like, oh wait, the status quo is fixable. How we fix it, we don't know, but let's start doing experiments to see what alternatives exist.
Yes, I have it brings me to a great point. I think both presentations are fascinating, and I personally am so immersed in technology as well, and blockchain and Web3 at this intersection of digital health and healthcare, that I want to jump in with a million questions. I know we have limited time, but for example, how do you see, like, I think that a general question that linked, someone asked about security, but more than security is, how do you see in a practical way, perhaps Leo, you mentioned the EHRs, and so how do you ensure privacy in healthcare if blocks are immutable and openly visible? And if you can, like, drill down a bit more in the hash or no hash, and if some of the data is going to be kept off chain, or in the clinical record, and some of the data is going to be on chain, meaning in the blockchain. And if that happens, if data is partitioned in that way, wouldn't be like still maintaining the status quo to a certain degree, and some data would in the end be centralized again when we try to decentralize? So that is one question.
It is a very big question indeed. But about hashing, just not to use computer terms, let's explain it this way. We have a product, and then we have a description, and then we have a description of the product. And in this description, out of this description, we take the keywords. the keywords like in Google. So
Like
this,
the metadata,
yeah,
right?
yeah, exactly. So this metadata, these keywords, are stored on blockchain, while the underlying data is stored off-chain. So that's and blockchain allows to exchange and transact only the hash data, not only hashes, not the data that is underlying. So that's one of the conceptual approaches to secure, namely health data. But about the question of how blockchains help security, and it's there are a number of, well, first of all, because data is encrypted in any blockchain, and the encryption keys are distributed. So no one person or entity has the universal key to everything. You need to have everybody has only a part of the coin.
The 1906.
Oh,
Sorry, I can hear somebody talking on the background.
It's happy.
All right. So it's maybe if you might have seen movies where they show how in the Middle Ages you would have one coin and then you cut it with a sword. You give it to two different people, and the door will open only when these two people meet in front of this door and put the coin together. And that's imagine that this coin is divided not into two but into 1 million parts, and they all have to meet in front of this door, and they all have to put this 1 million pieces together, and then the door will open. That's another conceptual approach, and then there are quite a few others.
Yes, and in talking about that, like partitioning the data in on-chain and off-chain, right? The off-chain part would be within the EHR of a specific hospital, for example, or a doctor or provider, right? So that, that piece of data and that sort of partitioned identity in the end would be still as it is now. So it's like, in order to apply blockchain to HR or clinical records, we should get to a compromise of the existing infrastructure, data infrastructure, and institutions, and obviously respecting the laws that exist and that will be made, and regulations.
There is another important point that you are raising here, is that everything that relates to electronic health records is really sensitive in every country.
Yeah,
and because we're talking about health data. The 3 days ago, hackers stole health data of several thousand Australian celebrities and are now demanding ransom, and it still goes on.
Yeah,
and so there are quite a few problems there. So of course the natural reaction of healthcare providers is to just have it all to myself, just to keep it and not share it with anyone, and it's perfectly understandable. But what blockchain allows is to distribute this data between many parties, and no one single part can be used alone.
Right. And as you said, the blockchain doesn't store the data, it just permits access.
Well, you can either you can also store the all data on the blockchain, but of course usually when we're talking about health data in sort of mainstream projects, they would only store the hash data. There is another important concept that we did not mention here yet. That is the concept of dynamic consent. That is that where blockchain is perhaps to the best of my knowledge, is the only technology available now that in practice allows for dynamic consent. The dynamic consent is the following: when you do say, clinical trial or any other medical research, you are required by law to provide to obtain consent from a patient, and in practice, they healthcare providers or researchers try to get a universal consent for everything forever, irrevocable, simply because they don't want to go back. It costs them money and time. What blockchain allows is the so-called dynamic consent. That is, you can give only partial consent. You can grain consent into only into the identifiable data, non-identifiable data, only pieces of data. You can with blockchain you can allow particular groups of providers of researchers to access your data in the future, and also you can revoke it automatically. That is very important.
You can change your mind.
Yeah, and that's why I was asking about patients selling their data, if they were interested in that too. So, yeah, as a possible. Go ahead.
All of these are, I mean, how, you know, two questions come about. You know, one of which is like, are these desirable situations? And then if they're desirable, how do we make them happen? And I think right now, in the we're still in the infancy of blockchain as a technology being used on a widespread basis, is that we have to be able to say, well, you know, again, what happens if we're not doing this? Because you know, I think like COVID has taught us quite a lot of things. For example, COVID taught us or has shown us what happens when we change the standard of peer review from you know an unknown number of days to 60 days or less, which became the new standard. And as soon as you see that happen, you start saying, well, wait a minute, if we could do this for COVID, why don't we start insisting on this for other fields as well? You know, once we're able to see what happens where, you know, if you have a set of data and the researchers make it available and other people are able to make discoveries out of it, perhaps even before the original researchers do. This is very annoying, of course, and there's sort of the larger question of about, you know, ethics and publications is its own story. But if lives can be saved by data, if lives can be saved by people, and you say, look, let's combine this data set with that data set to be able to find what works right in the middle. These are all, you know, how we do it with blockchain. That's one question. But these are now capabilities that people are saying, like, oh, we can do this now. A patient who has a rare disease is able to say, like, all right, yeah, Kaiser or National Health Service or whoever it might be is not acting on my data, but I will find a group which can act on my data, which gives them a lot more agency and autonomy over their own data than they've had previously. And that is that's really good.
I'd like to close with this question since we're a little bit over time. A student asks, what's the best way for a young student to get a hand in the pot for the development and mass adoption of blockchain? There are several young students who have limited exposure to the topic, including myself. So why don't we go ahead with that and then we'll wrap them.
One of the things I've observed is sometimes people who are experts in a field, if they understand a problem really well, they'll believe that only they can come up with solutions, or they'll have the sense that, oh, they've developed a solution, they're going to find the best application of it. And this is a testable hypothesis. If there is a problem that you know of, that you've learned through your own personal experience or in talking with others, you know, the nice thing about innovation today and these large number of widespread technologies, as I was saying, you don't need to be able to build a car to be able to drive a car. You don't need to know about how to do blockchain necessarily or all the different flavors of it, but saying, what are the capabilities that blockchain has given us? Does this apply to this problem? Let me bring a group of people together to start working on it. And what you have to do at that point then is start to practice. You know, you're coming up with ideas, you put them out there, you see what other people are doing. So you can be solving a problem, you can volunteer with other people who are working on problems. And don't get intimidated by the technology. because again, the capability of the technology, you can work with that even if you don't know exactly how it works. You'll pick that up as you're going along.
Yeah, I
Leo?
would like to add to what Catherine just mentioned, is that the best way is to take a problem that you work with and try to adopt and try to see if blockchain can help here, if you can do something better than others. You know, I'm so fortunate in my daily life, I work with future concepts. So let's take the for a moment, let's take the idea of Linda one step further. Let's have a look. Let's look at a human being as a data repository. Because what makes us unique? I mean, we are all there are millions of people in the world who have exactly the same hair color as me, and there are other millions who have exactly the same height. But it is the combination of all these features that makes us unique. And everybody who knows anything about cryptocurrency, when I say these things, immediately talk about non-fungible tokens. So we can imagine that in the future and in the near future, everyone will have a non-fungible token in order to be able to sell, exchange, and obtain other people's data.
And to answer the students' questions, we'll talk to Chris and the Society for Healthcare Innovation and see if we'll be putting on any seminars on this. I think there's a great need for at least getting the basics of how it works, not necessarily becoming an expert, like Catherine said. So thank you both very, very much. I wish we could do the breakout rooms, but I'm getting the signal from, let's see, our president here that we need to wrap up. If you want to come back and do breakout sessions tomorrow, we are here again tomorrow, Wednesday, Thursday, Friday, and Saturday. Thank you.
Thank you all. I have a million questions. We haven't even touched on NFTs or new social media on blockchain that can enable, patient provider relationships. But so I leave you with those questions for the future, and I hope to see you soon again.
Perfect. Thank you very much, everybody. Awesome.
Thank you.
Thank you for our speakers. Thank you for moderators. And thanks for all the participants. I see you guys tomorrow and, of course, in a year. Have a good day. Bye-bye.
Bye.